example to understand this. I just showed you this demo is to understand what edge detection is there, what is a filter, what is convolution. Now, when you have understood this basic thing, convolution you have understood, then we can move on to CNN basic. We are considering two images here. One image is X1 and the other image is X2. Now, in this image, what is happening, if you figure, both the images are showing a letter X, but one letter image X1 has a letter X, a very symmetrical figure, but X2 is not an X which is written in a very symmetrical fashion. It could be an X. So the alphabet X are shown in image X1 and X2. So what we are doing is, we are arranging both for X1 and X2, we are arranging all the pixels in a straight line. The first 6 pixels are here. After that, the second row is laid out over here, and so on. So you see this first row, these all 36 pixels are representing X1. These 36 pixels are X2. And then what we are doing, we are comparing these two. And after comparing, in the result, we are taking wherever there is 10, we are comparing both the pixels, and where there is higher intensity, we are taking it. So 10, 1, 10. 1, 10, result is 10. 10, 10, obviously 10. Wherever there is 1 and 1, we are ignoring it. We are not taking it. So the result is like this. Result is richer than the actual images. Now, when we reconstruct the result like this, now from this result, we have reconstructed this figure. See, this is the figure which is reconstructed by the result. If we take the 1, 2, 3, 4, 5, 6 pixels I have taken, and they are arranged here. The next 6 pixels are arranged in the second row, and so on. So you see this particular grid, it is almost looking like an X still. So what we are trying to identify, we are trying to identify whether the second image, whether this image is X or not. Now, suppose I do not take, I assume that I will take only 10 when both the 10 are there. So I'm ignoring this 10 and 1, I'm ignoring this 1 and 10 also I'm ignoring. I'm only taking those pixels which are both 10 in X1 grid and X2 grid. So the resultant will be this. If I reconstruct, it will be like this. And still it is looking like an X, however a smaller X, but it is looking like the figure of an X. So if you look at both the figures, they are still resembling X. Now we have understood what is feature extraction. We have understood how the images are compared pixel by pixel by the computer. That's a very basic technique. Now we come to the convolution neural network, where now at this moment I'm assuming that you already know what a neural network is. In neural network, at one end the input is given across several layers that is processed, and then the output is given to the output layer. So input layer takes the input, hidden layers in between process the input in various forms, and then output is given to the output layer, which is at the other end. So similarly, convolution neural network performs the same thing by using convolution. Taking our same example here, you see this is the image of X, and it's a grid of 6 by 6. There is a filter, and when the convolution has been performed on this, the features are extracted here. Now, in a convolution network, there could be several layers of for convolution, and there could be multiple filters. So one filter might be detecting the edges, another filter might be detecting the color information, yet another third filter is there which is trying to figure the corners. Another filter could be there which is trying to take out the curves in the image or the intensity of the pixels. So there are several filters, several hundred filters are there for extracting various features of the image. And in a convolution layer, there could be there are usually more than one filters. And each filter is supposed to take out a particular feature of the image. So here what is happening, you see in this example, there are three filters available here. 1, -1, -1, -1, 1, -1, -1, -1, 1. The various combinations of 1 and -1 are arranged in the grid of 3 by 3, three unique combinations. And these I'm going to use them for convolution on the actual image. So these are the various filters which are being used in the convolution layer. One by one, these filters are applied on this image. For example, if I take this filter, and I apply this on the image, you see the output and the figures have changed. If I apply this filter, I copy paste it here. See, again, the values have been changed. So different features are extracted. Different set of number is coming out. So we are applying three filters and different sets of numbers are coming out of it. That is called feature extraction. And these different three sets of numbers are shown here. This is the result after convolution. So this convolution layer has given me three convoluted images, three convoluted set of numbers which are representing different features of an image. One output could be having all the edges in the image. Another output could be having all the corners in the image. Yet the third one could be denoting the various intensities of the pixels in the image. So these three information, edges, corners, and intensities are taken out. And then these three will be fed into next layer that is called ReLU layer, rectification linear unit layer. The rectification linear unit layer is taking these three as an input, and what it is doing is it is simply checking each of this set of numbers and converting all the negative numbers into 0 and all the positive numbers as they are. See, you compare these two. -12 is converted into 0, -30 into 0. So you see only positive numbers or 0, a set of 0 and positive numbers, they are converted into this. This is done to suppress the unnecessary features in the image. The unnecessary features in the image are removed so that a lot of computation is not gone unnecessary being done by the computers. So to scale down the processing required by the computers, this is done. All the negative values are removed and they are replaced by zeros, because multiplication with the mathematics with zeros includes lower CPU cycles. So this is what happens just to remove the load on the computation by the computer. This ReLU layer simplifies the data set. The data set is now simplified by the ReLU layer. Now this is given to another layer that is called pooling layer. What pooling layer does here is, pooling layer again downsizes the image into its smaller form, and it becomes easier for the computers to process the image again. What happens on each set, a window is taken. That window could be 2 by 2, that window could be 3 by 3. The size of the window is decided. Here what we are doing is, out of this window, whatever is the maximum number, that is only taken out. Like here it is 15. Then we shift the window to the next number, to the next set of pixels. Here it is 6. Then we shift the window to the next set of pixels. Here it is 0. So this way, for each shift of the window, the maximum number is taken out. Now you can also decide, depending on the requirement, you can also decide whether the window will be shifted by 1 pixel or 2 pixel or 3 pixel or how many pixels. That is called stride. Stride is number of pixels you will skip while shifting the window. So here I have taken the stride as 2. See, stride is taken 2. So the first position of the window is here like this. It is giving me 15 over here. And then I'm not shifting the window by 1 pixel, but 2 pixels. 2 pixels after this, I'm getting 0 here. Again, if I shift it down, it will be by 2 pixels. And if I begin from here, I take maximum value out of these pixels 0. Next shift of the window. Now out these pixels under the window, they are giving me 24. And the same process is applied on the other grids of the features, grids of the numbers. So here it is. And this is what you get. So as you see, because of pooling layer, the image is again downsized further. And then all these features are arranged in a row in a straight sequence like this. And this straight sequence is called fully connected layer. In fully connected layer, every value of the pixel is given a particular probability. And depending on that probability, computer tries to predict whether this is a car, this is an animal, or this is a fruit. So this is what I actually explained to you. The image at one end is the input to the convolution layer. Feature extractions happen by convolving the image with the help of a filter. And then it is given to the rectified linear unit layer where it eliminates. It is called an activation function. It eliminates all the negative values, converting them to 0. Positive remain as they are. Then that output is given to that input is given to the pooling layer. Pooling layer removes unnecessary features by max pooling or average pooling. Average pooling mein what happens is in the window, instead of taking the maximum value, all the values are added and their average is taken. So it could be max pooling or it could be average pooling that happens in pooling layer. And the image is further scaled down into a very small image, which is containing the exact feature which is there. One exact feature would be the edge, one exact feature would be the curve or a corner. So all those exact features are taken out of the images and then they are arranged together in a straight vector. That vector is called fully connected vector and that is called fully connected layer. And each pixel is representing a particular feature of the image and each pixel is given a weightage for prediction. And by analyzing those values of the computer tries to predict whether this image fits into the class of a cat, into the class of a car, into the class of an aeroplane or whatever it is. So this is how conceptually a CNN works. There are certain images of different type of images. See, over 7 images are here. Circle, heart, various stars. 3D images also there, cube and a rectangle. And these are the filters. You are filtering them on the basis of color, number of sides, number of arms. Is the image 3D or not? Number of planes in the image, number of notches. So when you consider these filters 1, 2, 3, 4, 5, actually these are the features of the image. If you talk about color, blue, pink, green, whatever, number of sides. Circle has no number of sides. Heart has no number of sides. Number of arms. Number of arms, a 5-star has 5 arms. Heart and circle do not have arms. Fine. Similarly, other features are there. Now, this is the training data. By the help of this data, we are training the students. We are training the machines. The students are representing the computer. So the training is done. We are able to identify the color, number of sides, number of arms. Is it 3D? Only this cube is the 3D. Number of planes, number of notches. Notches means khanch. Notches, heart mein 1 notch hai. 5-star mein 5. In this 8-armed star has 8 notches and so on. This cube and rectangle or square or circle do not have notch. So these are the various features and these numbers are actually representing. You can even give the numbers to the colors. So these are the numbers and these numbers are actually describing the image. So first hidden layer. In the first layer, we are putting 2 filters. I told you that every layer has certain filters. So in first layer, we have taken out two filters, is 3D and color. On the basis of whether it is 3D or not, we are grouping the images. So the students can, some of the students can play the role of a filter, 3D filter. Another student can play the role of the color filter. Yet another student can play, so each student can play the role of a particular filter. And according to that, they can classify the images in the groups like this. See, number of arms. They do not have any number of arms. These have number of arms, number of notches. So this classification is done. There are 4 hidden layers. Number of planes is the last filter. And accordingly, the grouping has been done. Now, this is the training. The training of the CNN has been done. What next is required? The testing. The testing of the CNN is being done by this shape. You see here on the right-hand side, this one, we are going to test our logic by the help of this shape. This shape is a star, 5-sided star, 5-sided star is here. But this has black color, which is not here. There is no figure which is black, but still the CNN should be able to identify it by the help of other features. So there are 1, 2, 3, 4, 5, 6 features are there. Out of these 6 features, one of the features is missing. So the CNN should be able to, the student should be able to identify, should be able to classify the image as a 5-armed star. So what they will do, you will ask them one by one, start putting the filter on this. Is this star a 3D? No. A separate classification. Is this star blue colored? No. Is this star has how many number of arms? 5. So which category does it fall in? So this way, just by applying this particular filter, because there is no other image which is falling in the category of 5 for number of arms. So number of arms uniquely are applying to this 5-armed star. So only by third filter you can predict that, okay, this is a 5-armed star. And it is not of green color, it is of different color. So this way, you can give them a feel, you can give them the feel of the concept, the understanding of the concept, how filters work, and what is feature extraction.